to the third set of notes in our series and sequence unit. This is called finite series. So our first type of finite series is a finite arithmetic series. So an arithmetic series is a series whose terms form an arithmetic sequence. And this is when you have a pattern of adding. So the sum S sub n of a finite arithmetic series, a sub 1 plus a sub 2 plus a sub 3, all the way up to the last term, a sub n, is the number of terms divided by 2 times the first term plus the last term. Okay, where a sub 1 is the first term, and a sub n is the nth term, and n is the number of terms, like I said. All right, let's go through and do some examples. So, example, find the sum of the series. I look at this. I see it is in fact arithmetic, which means I can go through and write down three things. The number of terms, in this case there's 6. The first term, a sub 1, which is 10. And the last term, a sub 6, which is 35. And then I just plug everything into the formula. S sub 6 is equal to 6 divided by 2 times 10 plus 35. And this is just 135. Next problem, same thing. A little bit of an issue here because we don't know what n is, but we can find it by writing the equation. I know a sub n is equal to 14 minus 6 times n minus 1 because there's a pattern of subtracting 6 each time. And I know the last term is negative 46, so if I do negative 46, is equal to 14 minus 6 times n minus 1. I can go through and solve for n. It turns out n is equal to 11. Once I have these two things, I can say what a sub 1 is. It's 14. And then I know the last term, a sub 11, is going to be equal to negative 46. Plug them into my formula. I can find the sum of the first 11 terms. This is going to be 11 divided by 2 times 14 minus 46, and this is equal to negative 176. All right, you can also see word problems. You might not see these in the IXL stuff, but hey, I could throw one at you. You never know. So it says in an auditorium, there are 8 seats in the first row. The number of seats in a row increased by 1 with each successive row. How many seats are in an auditorium with 10 rows? Well, the way we do this is by first figuring out what the first term, last term, and n are. Same as the other problems, it just has some words. So it says there's 8 in the first, so I know a sub 1 is equal to 8. I know n is going to be equal to 10 because there's 10 rows. And then I need to find the a sub 10. Well, I need to write a formula for this, so I know a sub n is equal to 8 plus 1 times n minus 1. If I plug in 10 right here, I get 8 plus 9. 8 plus 9 is 17, so a sub 10 is 17. Plug these into my formula. I got s sub 10 is equal to 10 divided by 2 times 8 plus 17. See what that is? Turns out it's 125. Let's label that as seats. Okay, so arithmetic series, there's a formula that you can use to calculate it. You do not need to go through and write out each term and add them together like we were doing in the last section, but only for arithmetic and also geometric series. That's why you should be excited when you see these. There's a formula that you can use to find the sum, only if they're finite. Like, that's the key word here, finite. If it's finite, you have a formula. If it's infinite, you may not have a formula. So a geometric series is an expression for the sum of the terms of a geometric sequence. The sum of a geometric series, like this, is just this expression here, where a sub 1 is the first term, r is the common ratio, and n is the number of terms. So let's go through and do this. We need three things. We need the first term, the number of terms, and the r value, the constant ratio. A little bit different than the last one. So here's what we do. A sub 1 is the first term, 3. R is what's happening each time. This one's times 2, so R is 2. And then N is the number of terms. I counted 6 terms. Plug them into the formula. I got S sub 6 is equal to 3 times 1 minus 2 to the 6 divided by 1 minus 2. This is clearly 189. That's all you got to do. Write down the things, plug them into the formula, evaluate it with a calculator. Because I can't stop you guys from using calculators, so why would I have you do it by hand? This one, same thing. A sub 1, R, N. There's 5 terms. Each time I'm multiplying by -3, and the first term is -45. Plug them in to find S sub 5. S sub 5 is -45 times 1 minus, careful with your parentheses, -3 to the 5th, all over 1 minus -3. Throw this into the calculator, being careful with your parentheses, and you should get -2,745. Alright, this is where it gets interesting. You have to be able to recognize if it's arithmetic or geometric or neither. If it's neither, you're screwed. You have to write it out. If it's arithmetic, use the arithmetic formula. If it's geometric, use the geometric formula. This first one happens to be arithmetic, which is very exciting because all we need then is the first term, the last term, so there's 32, so it's A sub 32, and the number of terms, which I already said was 32. To find A sub 1, you want to plug 1 into this expression here. So I got 4 times 1 plus 7. 4 times 1 plus 7 gives me 11. A sub 32 is going to be 4 times 32 plus 7, and that just happens to be 135. And then I just plug everything into my formula. S sub 32 is equal to 32 over 2, so n over 2, times the first term, 11, plus the last term, 135. And we see that this is clearly 2,336. Our next term, I notice right away, it does not start at A sub 1, it starts at A sub 8. So that's still my first term in my series. That's where I'm starting, so that's okay. You don't need to go back and find A sub 1 because you're starting at 8 in this series here. So A sub 8 is equal to 48 minus 3 times 8, which just happens to be 24. Then I got the last term, A sub 21. This is going to be equal to 48 minus 3 times 21, which is -15. And then I go through and I think, well, how many terms are there then? There's not 21 because it starts at 8. What I like to do is I like to do this thing, 21 minus 8, but that takes away all 8. I got to put back in the 8th term, so I do plus 1. And this so happens to be 14. All right, plug everything in then. I got S sub 21 is equal to 14 divided by 2 times 24 minus 15, which is equal to 63. I used a calculator. All right, these next ones, they're both geometric. So let's go through and do that. Things you need for geometric are A sub 1, the first term, R, the ratio, and N, the number of terms. Well, this one's real easy. My first term, I'm going to plug in 1 just to be sure. 5 times -2 to the 1 minus 1. All right, this is the same as -2 to the 0, so that's really just 5. R is always the thing being raised to parentheses. It's -2, and N is the number of terms. In this case, there's 10. So then I find S sub 10 by using my formula. 5 times 1 minus -2 to the 10th. Again, be mindful of your parentheses. 1 minus -2. And this ends up being -1705. Throw it into a calculator, see what you get. All right, this last one, also geometric. Let's go through and be real careful. I got A sub 1, 4 times 5 to the 0, which is just 4. Always plug in this number. Don't just assume it's going to be the number in front, even though it happened to work out that both of these were my A sub 1. sometimes it does be like that. All right, say what r is. It's always the thing being raised to the exponent. Say what n is. In this case, there's 14 terms because you have 13 plus the 0, so that's 14 total. That means s sub 14 is equal to 4 times 1 minus 5 to the 14th divided by 1 minus 5. When you plug this into your calculator, you get the simple number of 61035155624. Nothing too crazy right here. Alright, thank you guys very much. I hope you enjoyed the relatively short notes today. Be careful doing the IXL assignments. There's only 2, but I want you guys to make sure you practice using these formulas. Watch what you're doing, use your calculator, don't make any mistakes. Have a nice day.